All right, gang, today we're going to be looking at counting molecules. And we're going to be focusing on one of the more foundational aspects of chemistry. And that is, what is a mole? A mole is a counting unit. It is the standard unit for counting in chemistry. The way that we abbreviate it is MOL, not M. M is for mass. What is a counting unit? Well, you already know what that is. A dozen equals 12, right? We use this term, a dozen, to represent a certain number. It allows us to count certain things in a different way to make it a little bit easier. Another example would be a ton, right, which is 2,000 pounds. An hour would be a counting unit for 60 minutes. It's just a substitute to take numbers and make them a little bit more manageable. Now, in chemistry, we don't use a dozen to count atoms and molecules because they are extremely small. For example, in 18 milliliters of water, there are 6.02 times 10 to the 23rd number of molecules. This is a number that is not possible for you to comprehend how big and how large it is. If you had a 12-ounce bottle, this is how many molecules it would be. The whole point of a counting number is to take this value, 1.19 times 10 to the 25th, something human beings have no reference for, and to make it something that we can actually comprehend. So if we were to try to reduce this into a dozen, as you can see, we don't really get a more manageable number. A number this big is just not practical for us to use. And so this is what the mole is. It's basically the same thing as a dozen, but instead of it representing 12, it represents a gigantic number. We call this number Avogadro's number because he's the Italian scientist that discovered what it is. And so in the same way that a dozen means 12, well, if you had a mole of donuts or atoms or molecules or cars, this is how many of those things you would have. And so going through the same calculation in a 12-ounce bottle, instead of some ridiculous number to the 23rd power, you only have 19.7 moles. This is a number that we can comprehend. It's a number that we can actually manage. The next thing we're going to talk about is molar mass. Molar mass is the mass of 1 mole. So if you had, let's say, 1 mole of carbon, or 6.02 times 10 to the 23rd atoms of carbon, how much would it weigh? That's what the molar mass is. Now, you'll often see other terms, potentially molecular weight, molecular mass, formula weight, formula mass. They all mean the same thing. We're all talking about 1 mole, the mass of 1 mole. So the way that we find this out for atoms is it's pretty easy. You just look on the periodic table. And the mass that's there, that is how many grams 1 mole weighs. So for example, a mole of carbon, if you look on the periodic table and you find carbon, the mass of 1 mole would be 12.01 grams. If you had oxygen, look on the periodic table, find oxygen. How much would 1 mole weigh? 16 grams. Hydrogen, 1.01, and so on and so forth. The unit for molar mass is grams per mole. If the molar mass is the mass of 1 mole, then the unit should hopefully make sense. It's the number of grams per 1 mole. Now, the way that we calculate it is pretty simple. You'll want to write all of these down, which is why it's highlighted here, is we need to know the number of type. We need to be able to find it on the periodic table. You multiply the two and you add it together. Now, if it's just for an element, that's pretty easy. You just add it together. But what we really care about is compounds. So here we have a compound, calcium bromide. The first thing we want to do is determine how many of each element we have. So for calcium, we only have 1, and for bromine, we have 2. The next step would be to find them on the periodic table and look up their masses. So for calcium, it would be about 40 grams per mole, and for bromine, approximately 80 grams per mole. We would then multiply those two together. So that's pretty easy, times 1, and then times 2, we would get 159.82. And then the last thing is we just add them together. And so we would get a molar mass for calcium bromide as 199.9. So we're just adding up all of the parts. So here's an example with parentheses. So here we would be thinking about our math class. We would be taking that 2 and distributing it inside the parentheses. So our nitrogen would be 2 and our oxygen would be 6. We then look on the periodic table to find all the molar masses for each element. And then the next step is we would multiply all of those together to get the masses of each element. And then our fourth step is we would add them together for 211.64. So that would be the molar mass for this compound, strontium nitrate. Okay. So here is an example. So go ahead and pause the video and see if you can get this one. And as we go through, you should have an answer of 78.01. And that's it.